Yes, perfect. So, yeah, thank you for being here. So, it's a pleasure to talk to you and, to show you some great marketing slides and some other stuff. So, no, just kidding. So, hopefully, there will be some marketing trust. So, I work for a US company, so that's somebody perhaps what you're used to. But I would like to show you our approach, how to deal with the threats and the problems we see in the world in terms of cybersecurity. And perhaps not to paint everything black or white, so perhaps to paint it a little bit orange, but to give you some ideas what Cloudflare idea is about the challenges we see, what we can do to help you to secure networks, your applications, how you can build applications, and take the best out of it. So I think we all know, so can it get worse? So we live in times where a lot of things change, where nothing stays for a long time. So we have this orange guy sitting in the White House telling us about terrorists every day, and things are changing, things are popping up. Yesterday he was the best buddy of Putin. Next day he's laughing about it. I don't know what's happening tomorrow or today, so we don't know it. And same with the other guys. So I think that's a fact that we cannot expect something as written as it was in the past. So it's a lot of change, and I think that the same change is something we see in the IT and in IT security world quite a bit. So at some time, so when I started 15, 20 years ago with IT security, we said, I don't want to have anything on the endpoint, get away with all these agents. I would like to have everything centralized. Then we stepped back and said, okay, now EDR systems, so like CrowdStrike, SentinelOne, Microsoft are everywhere, and that's the only way where I think security on the endpoint is possible. So we went also back and forth, but I think there are a couple of things that will persist and will not change in the next years, and that's how we distribute networks and how we connect stuff. So, but as an US player, or all these cybersecurity vendors, regardless if they are from Europe, US, Israel, or wherever, we are pretty good in finding buzzwords. Yeah, to say, okay, we have Zero Trust, ZTNA, we have CASB, we have DLP, and all these things. Next generation something is also always something that you see in the marketing slides. But what is it? What is it? And I think it's like patching in a different way. So it means we have an environment, and that's perhaps a typical customer environment can look like, your environment can look like. We have databases, we have applications, we have distributed networks, all that stuff, and we have new challenges popping up. So as you said, the world is changing every second, but the industry makes it a little bit, or not really easy, because we say, okay, now there is the threat of endpoint, so you need an EDR system. You don't need a firewall anymore, you need a next generation firewall that's application aware. And then you need CASB, you need all this. So we find words and we find things and we find features to stick it like labels on a map to say, okay, here's something you need to have, you have to have, and that's how you fix your network. And then there are all the old terms like MPLS lines, so quite expensive telephone lines from A to B. Then there are other things. But one thing that always is a problem is first of all, they're just point solutions. So they don't work together. Means there's a CASB system, perhaps trying to control Office 365 or other services. And in parallel, there's from a different vendor, a secure web gateway that tries to control your up and downloads and perhaps tries to deal with DLP and other features. So it's not really like an army that is able to work together and to say, okay, here's a benefit that I can bring, there's another benefit, let's work together and work cost effective on the other side. So in these days, we think Money is not a problem, so everything which is related to security is just a check that the government sends to you and you can invest, but in reality it looks a little bit different. So we need to think about the efficiency and also about the knowledge we have. So I think there are a lot of people necessary to maintain 10 different vendors, but we don't have really 10 people that are really professionals in all of these 10 areas. So we need to consolidate that perhaps a little bit. And another thing, if we focus on security and especially on networking, which is for me somehow the base, because that's something that's always necessary, we moved away, and I'm fine to move away from the centralized approach. We said we put everything in our castle, so we put all the hardware in our data center, we put all the security stuff into it, the database is always in our data center, and then we have some offices and that connect to the headquarter and stuff like that. So, but we moved in the last, I would say, 5 years, so definitely when Corona starts, to a more distributed world. Means today the database was perhaps in the data center, one floor above you or below you. Now we just move it to Azure, to AWS, to GCP or whatever, so it's no longer our property. But if we really break it down to what it is, and that's what, for me, cloud computing and all these modern terms stands for, it's just another data center. Yeah, so you don't maintain the data center, you don't need to send somebody to AWS somewhere in Frankfurt or so to say, okay, please patch my underlying hardware and check if the cables are fine, if the powering works and stuff like that. You give up this responsibility, but at the end, there's a part of a system that you're using that's perhaps reserved for you, where you have control more or less over, but it's just another data center. Yeah. Same if you say, I go to Haussmann, which is a German cloud provider or whatever. It's the same thing, just a little bit smaller than AWS, where you say, okay, here are the internet lines, here's the room, put in your hardware, power up your server, and go for it. Yeah? It's just another data center, but with a lot more of challenges, how you can connect to it. Yeah? How quick things can change there as well. Yeah? So I don't know how many developers are here in the room, but for me, developers, security is always a conflict somehow, because they are really flexible, they have great ideas, but they don't care about security. Yeah. So, but today that's totally fine. You can spin up code at AWS, GCP in seconds, and you can build complete full-fledged applications there within seconds, distribute them to the world, and the security team doesn't know about them. So it's a challenge. So moving from the centralized to the distributed approach is something where we need to deal with. So how we try to solve that game. So I think more or less everybody's hopefully aware and heard Cloudflare at before. So what we try to do is to take today's corporate network, however it looks like, yeah, in most cases it's distributed. We see VPNs, we see MPLS, we see tons of other stuff, and try to organize that in a new way. Means it's also at the end a centralized approach. So we try to take all these loose ends together and try to order them correctly and give them a certain stream. So it's a thing we call connectivity cloud. So where we take our network, and we talk about that network in a second, we take our network and say, hey, whatever you have on the planet, so regardless if it's in Poland, if it's in Eastern Europe, if it's in Germany, in the US, in Asia, connect it to our cloud. So the Cloudflare cloud is next to you, so it's not far away. So it means, okay, from here you need to connect to Warsaw most likely, but even if you're in Africa or somewhere else, there's always the data center close by. So even if you're in the Maldives or something like that, we really have a data center there, and we are able to serve that. And we take care, first of all, of the connectivity, so how data will eventually proceed from the Western world to the Eastern world, from north to south, regardless of where you are. If you're in Sydney, or if you're in LA, or if you're in Krakow or Warsaw, we are able to connect these things really in an efficient way together. And put in security directly into your connectivity stream. So means there's one thing where I like to compare it with is there are ways, so that's the typical US city, but it can be any city in the world. So if you go to Krakow during rush hours, I think you will expect the same. There's always a question, what do you use to get into the city, to get to the data, to get into the city center? So you can take the car, you will reach your destination somehow, yeah? So, but going in the rush hour, can you really count on it? So will it take 10 minutes? Will it take 30 minutes? What happens if there's an incident or some stuff like that? In the IT, we use technologies for that. We say, okay, we use SD-WAN connections or stuff like that. That works like Google Maps. Oh, there's an accident, so I find an alternative route around it. But it's not really predictable. It's not predictable what you can do today and what you can do tomorrow. The industry tried to solve it with MPLS lines, for example. They said, okay, we as a telecom provider, we provide you end-to-end connection. Yeah, we can say, okay, going from Vietnam to Europe takes 350 milliseconds with latency. Is it a good one? Is it a bad one? But is it really reliable? And at the end, is it really predictable? That's really a big question. So instead of using the car, and so I'm from Germany, so we are not proud of it, but there's another small country in Europe where you can count on the railway. Yeah, so if you go with Deutsche Bahn, it's not predictable at all. But if you ever been to Switzerland, for example, and you want to go from the Zurich airport to Basel, Lucerne, Geneva, or something like that, you can count on the train there. You can say, okay, the train is arriving at 9 o'clock, and it's arriving at 9 o'clock and leaving the train station 2 minutes later. And it's arriving 45 minutes. Always, I would say 90%. It's the case. There can always be failures, that's technology. And that's a bit the way how Cloudflare does it. So it means what Cloudflare does is we own, and that's where we came from, a global network. And I don't know if everybody is aware how big this network is. So today we are in over 330 cities worldwide, but that doesn't mean we are in 335 cities only. We are in over 800 data centers worldwide. Means we serve today 20%, 25% of all internet properties that are available on that planet. Yeah, so I don't know about ISS. We have something there, but 25% of the internet traffic is a big number. And that helps us in different ways. First of all, it helps us to connect the things. Yeah, so we have the control over this network. Even if it's that thing we call internet, we try to control it. Means coming back to the train example, we own the railway. Yeah, to say, okay, to come from A to B, you can take one of our cables, one of our backbones we have to connect to these systems. We define short routes to all big providers on the planet. So regardless if it's Meta, Facebook, AWS, and others, so we have direct connections to these providers and can connect directly to them. And this gives customers a big advantage so that they only need to connect to one of our data centers, the train station, get into the train, and if they want to go to Microsoft, to their application, they take really the fast lane and the controlled way. And that gives us the possibility, and I don't want to talk about these different terminologies here. This gives us the possibility to say, okay, we would like to secure this way because we own the most important part of internet security, and that's the middle mile. Yeah? So we don't own the last mile, so from your socket in your data center to your local provider, but from your local provider to your destination, we own the whole path. And that's where we put our platform approach of it. Means we take all these patches, what you have seen before, and try to bring them together into really one flow, into one solution. So what does that mean? So first of all, there's Cloudflare One. So and if you know CrowdStrike eventually for a while, so I don't know why you can't read the middle one. Our basics started 15 years ago with CDN and DDoS protection. Means Matthew Prince, our founder, had the idea to say, okay, let's create data centers all over the globe and cache data. So it's like a proxy. Yeah. So you say, okay, why should a picture loaded from the origin in Krakow when I can cache it in LA, in Germany, or in Asia? So he started to distribute all these data centers and started with CDN. And the next step was to say, okay, let's use that network also for DDoS. Means if we look at classical DDoS attacks today, they use normally routers and all that stuff to use them as bots to attack a network to create this massive bandwidth. And instead of sending all this traffic to a scrubbing center or something like that, we try to mitigate these attacks locally. And that helps us in having 800 data centers, at the end 800 scrubbing centers directly, because if you take all ASUS routers, for example, that are breached again to attack systems, if you take all of these breached systems and say, okay, let's go to your website and DDoS it, there are millions of it worldwide. But if you only take the area of Poland, there are perhaps a couple of thousands, 100,000 or so on routers. So it's easy to mitigate locally. And if you do this across 800 data centers, you have, first of all, a really big bandwidth and a lot of capacity. So that's where we started from, but that became a little bit of legacy. So we started to add security features like web application firewalling, connectivity, so saying, okay, you connect two branch offices to our cloud into your tenant, and if you would like to go from A to B, let's do it, use our network, and stuff like that. So it became really, with Cloudflare One, a big platform. But we have not stopped there, because we said, our idea is really to make the internet better. Say, why should you not execute your applications directly on our network? So, and that's pretty new to a lot of people I'm talking to, because they are used to create applications and all that stuff at AWS using Lambda and other stuff. So, but with Cloudflare and the developer platform, you are also now able to execute code directly. So you are able to run your application directly in 800 data centers just with one click. And that makes applications faster. That brings the security as close as it could be to your application, to your code, and secures this code. Yeah? And the same with other stuff, with R2, which is our S3 model or compatible data lake, where you can store data and stuff like that. So moving from a CDN vendor where you have your application, your server running in your data center somewhere, we started to say, okay, we give you the connectivity, but we also give you the compute power to run applications, to run your AI models, to run MCP servers and stuff like that directly, really across the globe. And that really helps us, because each and every data center you see is able to run all services. Yeah? There are always some features that take some time. So, for example, perhaps you saw it on the bigger slide, we are just deploying GPUs to all data centers. So 2/3 of our data centers are already GPU enabled. So by end of the year, it will be 90 plus that will be enabled with GPUs to run and host your AI applications. And that's all under one umbrella. And that's somewhere I would like to show you how you can really use this, how easy it is to use Cloudflare and how quick you can do this. So just need to pray to the demo devil that everything will work. So when you start with Cloudflare, so you always have this dashboard. And to connect to our system, it's pretty easy. So means when you want to on-ramp traffic, we have certain ways to do this. There's the traditional way to do this, to say I create an IPsec tunnel and just send it via IPsec to us. And the cool thing is you don't need to create 800 IPsec tunnels to us. You don't need to do it because Cloudflare also uses Anycast to connect, and that's the IP address schema we use. Anycast has the benefit that you will get one IP address from us, and this IP address is not only in the Warsaw data center, it's all over the planet. That means this IP address exists in Warsaw, Frankfurt, Sydney, Mauritius, wherever you would like to use it. Yeah? So that makes it pretty easy. Means to on-ramp traffic with, for example, IPsec, you just need to connect one tunnel. So I created one tunnel here, and I think my machine is down, so that's why you see it's degraded. But you see it's directly, or would be directly connected to over 600 data centers. Yeah, so with only one tunnel, you have 600 data centers, and even if one data center fails, it doesn't care. At the end, the traffic goes only to one data center, yeah, because we can't distribute IPsec loads to 600 ones. But in case this data center fails, or if there's a other data center which is quicker right now because of latency or whatever, it's just to rekey off your tunnel, which happens automatically, and the traffic goes to the other data center without any interruption of the traffic. So that's one way to do it. The other way to do it, and that's pretty cool if you are a little bit bigger, is we can interconnect with you. Means that because we have our data center most probably often really, really close to your data center, we can create a layer 2 connection to your data center or to your data, to your applications. I mean, we just spin up a cable, create a VLAN, and say, okay, here's your data center port in the switch, here's the other one, just create a physical connection. So that's also something unique, but it's possible, yeah, to get your systems directly to it. But the most easiest way to do it is Cloudflare D, and it's the most flexible one. Means with Cloudflare D, we use a small service connector that is able to connect to your system. So means it's super easy to install it, to get it up and running, and to scale it. So what I have here in my lab, for example, is I have a Synology NAS that's able to run a Docker service. So I just spin up a Docker and run this tunnel. So if you create a tunnel, besides giving it a name, that's if you do too many demos. It's just one command. So, and connecting your whole network to our cloud is super quick. So, for example, if you use Docker, it's just a simple command you need to run. And it spins up the Docker image, and it's there in 2 seconds, more or less. I'd say 1 minute. So let's do it quickly. So I just prepared my Synology just to spin up another instance of Cloudflare D. So I copy and paste that one here and put it in here and just need to rename the tunnel. That's the demo devil. Okay, and just deploy it. And it's really quick. So it should be started. And if I go back to this one here, I not use that one here, I use my Synology tunnel. I use the same connector, so what you should see now is that there are a couple of connectors. So that's the original one, but if I go to Synology, you should see now, whoops, two connectors here. So before there was only one connector, otherwise I wouldn't be able to access my NAS system from here. And now there's a second one. And I could now spin up 10, 20 of these connectors in the same way. They will automatically do load balancing and all that stuff. And first of all, I just put a hook into my network. The next step is, okay, I have the tunnel created, and I can just say, okay, there's a private network behind it. So that's my network at home I'm connecting to. And if I enter that one here, it's automatically connected. And if I have a second branch somewhere in the globe where I do the same, I just enter the network here, and this network is there, and we create automatically a route and stuff like that. So it's super easy. Next step, and that's something I would like to show you, is just make or publish an application. So I have tons of applications running in my lab. Yeah, I'm a smart home guy, so if you play with smart home, I'm not only driving my wife crazy because every day a switch changes and she needs to turn on the TV in a different way. She gets crazy on that. But it's also nice for demo proposals, because what I do is, first of all, very simple. I say, okay, I can connect to my home assistant, which is not really special, to my network. So I put it in here. I'm already logged in, and now I could enter my home assistant instance at home easily. But this goes all through the tunnel. Means if I would troubleshoot that tunnel now and go into it, and that's what I see here. First of all, which is pretty cool, this connector is connected to 4 data centers in parallel. Means also from an HA perspective, I'm super flexible here. So if one data center in Frankfurt goes down, we just take another one. And as you see on the numbers, I think there are nearly 20 data centers we have in Frankfurt alone, which is really impressive. But I can also stream the log files here, so I see directly what's happening on this tunnel, and it's going on, and it's just the refreshing of my stats that are in my home here. So it's super simple, which also helps for transparency. So if you would like to see what is really going over this connection, you just need to turn it on and look into it. So super easy. So once I'm connected to it, I can now do different things. So name of the presentation was, trust nothing, secure everything, and that's exactly the idea. So just would like to take you a little bit with me on that journey to say, okay, the next step is, if I just would say, okay, here's my Cloudflare D, here's the domain name HA dot something, you can access it. There's no security applied to it right now. There's no authentication applied to it right now. It's just a web page I publish to the world. So the next step would be to define an application here. To say, okay, let me go into the Home Assistant one. I could say, okay, here is my domain. I would like to publish it. And I put some policies behind it. So I could say I would like to isolate this traffic here. And that's the first step of security. Means currently it looks like I'm connected to this instance, but in reality it's just a picture or a stream of the application. Means we use browser rendering to present this application to the user. Means there's technically not 100% correct, a computer that just opens the website, sends the image via a stream to my desktop, follows my mouse movement and clicks for me on these certain buttons. So there's not a lot I see. So if I do a right click, for example, I don't see a lot here. I don't see the typical Mac or Windows pop-up menu. It's just a stream. And if I would now go into the code, it also would look completely different. It's just a JavaScript with perhaps 20 lines of code, which only is for our rendering engine. Super easy. How did I do that? Super simple. So I created a policy here that said, okay, I would like to isolate that one. And in the application, I click browser rendering here and enable that. So with just one click, this application is isolated and you are good to go for it. I could do tons of stuff more. So if I just go to that policy, I can apply policies and create policies based on different behaviors. So I could say, okay, I would like to create a policy that needs two-factor authentications. In my case, you need to use authentic to authenticate to it. But I could also chain different authentication mechanisms. I could check the endpoint to say, okay, is an EDR system running? Is it up to date and other stuff? So I can combine all that stuff and easily apply this to the application with really one click. And here's the isolation tab as well. So that's how I define the policy and secure it from a policy standpoint. So I don't know if you know or how good you know Home Assistant and all that stuff, but one way, or what I use at home, for example, is Alexa. To say, okay, I would like to use Alexa to turn off my lights and stuff like that, but I don't want to host some Alexa engine at home or run integration in Home Assistant. I would like to use the native stuff. So it means if I call Alexa at home, that the API call from Alexa goes directly to my Home Assistant to turn off the light and stuff like that. And that's a different way to do it. So if we check the applications here, there's another application called, it should be there, that's the devil. I use an API URL. And I haven't defined any application here, because if you use the Alexa API, so AWS at the end, it's pretty hard to deal with authentication. So they cannot use authentication. You could use certificates or all that stuff, but they just make an API call. And that's something I don't want to make possible for each and everyone. But it's the same server, it's the same application I use in my home lab. So how did I do this? So I just defined, that was one way too quick. I just defined in the tunnel, just defined in the tunnel not only one domain to this server, there are a couple of domains, and one is the alexa.dhn home. So it's the same IP address as you can see here, as here, but I use the web application firewall. So it's exactly the same way, the same stream, and then I just defined rules that only Amazon is able to connect to this one. And that's, again, in the same flow more or less, so I go to my domain, click on security, and I see my security rules here, hopefully. And I created the WAF policy for that. Means everything is blocked to Alexa, only the API that is responsible to call something is available. And then I put some other stuff so that the request needs to come from Northern Ireland because I don't want to have US calling my systems. I was really able to shrink it down. So that's the first one. In addition, I created an API shield so that this stuff in the background is learning automatically how the Home Assistant API is working to say, okay, if Alexa makes a call, it should look like a certain order, that they need to do this first and do that afterwards. So it's really step by step and not easy. And it's discovering, also from my other applications, new API calls frequently and gives them here to review so that I can really adapt these things. Going back to the connectivity again, another thing I did is I had a dashboard, I think everybody knows Grafana more or less, where I check my power usage. So it's nothing special, so it's just some boring charts and some other stuff. But believe it or not, there are thousands of calls every hour, millions nearly every day, because every time one of my devices at home changes the value of the power consumption, it will send a request and will put it into the database behind it. So bringing all these bricks together, I said, okay, it would be a great idea to say, okay, I would like to use Cloudflare Workers for that. So in theory, there's technically a way to say, hey, there's my influx database that stores the data from Home Assistant, and that's all done automatically by an integration. But for demo purposes, I said, okay, let's say I'm a manufacturer of these devices and I would like to send it to my database that is hosted somewhere for all of the devices I've distributed. So typical OT example. So what I did is really simple. I created a worker for that. Means I created a compute instance that's collecting or receiving the data from my Home Assistant, normalizing it a little bit, and then send it out to the database via an HTTP call. So really super simple. And I'm not the best coder, so ChatGPT was my friend, and I just put it into it, and then posted it into our worker platform. So it means that's at the end the code I'm using. So it sends out this HTTP post to the website and collects all the data from my devices into that. And that results into more than, already today, 400,000 requests. Not 140,000 requests in 24 hours. So, and that's not requiring any piece of hardware at the end. Everybody of you can do it today by just signing up to Cloudflare, because it's a free service we offer to write your code and do other stuff. But it's the same if you would like to really run complete applications. So we offer you the possibility to run the code directly. We offer you the possibility to use a database, everything. So we can run full stack applications here. And then, in the same flow as I just did it, we are able to apply security rules and connectivity rules to it. And by deploying this code, so this means when I deploy it and save it here, it's not only deployed to the data center in Frankfurt or Düsseldorf, where I live close to, it's automatically distributed to 800 data centers. So this code will not be executed if you're in Krakow in the US or somewhere like that. It will be executed most likely in Warsaw. And that's also from a user experience, a complete new experience. Cool. So going back to that, as I said, so that's just how quick you can do it. So meaning onboarding of an application just takes minutes. Securing it takes perhaps a little bit longer because you should have a plan what you do, but from a configuration standpoint, it also really goes quick and it's without any hardware. Yeah? So you don't need to think about, do I need the new best next generation firewall or something? You just connect it to our cloud and benefit from our services. And what I always think is, and that's what we see every day is, you can only protect what you know. So it means we provide you these services where we, first of all, give you an idea how the security landscape looks like. So I said roughly 25% of the internet traffic goes through our lines. Means we see most of the bad traffic somehow, really quick. We are pretty good in DNS security, means we see if a bad guy, for example, wants to create a phishing attack and use a zero-day exploit or something like that, all these attacks have one thing in common. They need to sign up for a website or for a DNS name. So they use, even if it's really a cryptic, long DNS name, they need to use a DNS name for that. Even if it's a random character, if you just hook on your keyboard and say blah, 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 dot something. We see these requests directly if they pop up. This also means we can be proactive to prevent attacks from these websites. We can block this website directly. And that's what we mean that we need to also evolve from being reactive to preactive. So we need to know there is something going on. There is a website from a bank popping up on a web server somewhere on the globe. We need to find that one, and that's one of our missions, and that's where we are really successful with. And then bring really all these security insight in our threat intel so that we can combine all these things and give the security analysts also all tools to figure out what's going on, and if there's an attack, to check what they can do and how they can do it. Yeah? We automatically discover the web assets in your network. We talked about the developers that sometimes run crazy by just distributing new applications. We would see this normally. Yeah? We would see it in your network when they connect something, and then we can also protect this stuff and give you also the overview about your threats and your risks. And that's a good example. I don't know if that pops up from time to time in LinkedIn, and that's where I have this photo from. It's a US bomber in World War II, and it's more or less the same way as we do IT security predictions today as well. So it means they did data-driven security as well. I mean, they said, okay, we see bombers coming back completely with holes, and they were hit by the enemy, but they fly. And there are others that has just one hit and they crashed. So why? So, and they used that data, they analyzed this data, what really is needed to fly a bomber, or that a bomber is able to fly, and then they protect the critical areas with more armor and stuff like that. They said, okay, the wings can be filled with holes, but if they fly, I don't care. But if the cockpit gets hit and the pilot is hit, I have a problem, easily speaking. And same for a lot of other areas. And that helps us as well, because we analyze these massive numbers in our network to give you really the overview with CloudForce One. So coming back, so again, taking all these resources, taking our philosophy to say, okay, security should be in the flow, should be in the connectivity cloud. You should connect your applications no longer in your data center. You should start building your next generation of your applications directly at the edge, where the user consumes them, where you can secure them, where you can scale the security. So we don't care if you have 10 customers today and you are a genius and everybody would like to buy your product, and next year there are thousands or 100,000 or millions of customers. We are able to directly give you the performance and the capabilities to do this. So again, that's how we help. If I have one message, keep this map a little bit in mind, and yeah, think about it. I don't want to talk about the DDoS stuff because we are a little bit running out of time, but the conclusion is there are tons of bricks with Lego or something. You need to put them in a good way together. Yeah, so you can create a rainbow horse easily with all colors, but you have to have a plan, and these things need to stick together, and if they don't stick, it will be a problem. Great. So, thank you for your time. So, more or less, we are on time. Enjoy the break.